So, dear all, followed by the previous session, that is, we discussed about statistical channel modeling. In continuation of this, today let us have a discussion about empirical channel models. So, first we see that statistical channel model we have discussed, and we are very clear that it is not considering the propagation environment. But here in the empirical we are going for two cases, that one is empirical and semi-empirical wireless channel models, and here we are going to give accurate estimate for the path loss, shadowing and small scale fast fading. Okay, and these empirical models are based on only the propagation environment, and this propagation environment which are going to specify the parameter method, that is in the propagation scenarios in different systems. So now we are able to differentiate what is statistical channel model and what statistical channel model is actually doing, and what we are going to discuss about in the empirical as well as the semi-empirical wireless channel models. Here these models are taken to some four parameters, like this the signal is getting arrived, this angle of arrival which is denoted by AOA, and angle of departure, that is AOD, then antenna array fashion, next angle spread and antenna array gain pattern, and other real-time factors. Okay, and this will exist such as suburban. Already I told that scenarios are environment, so we can take as suburban macro, urban macro, urban micro. So we know that small cells, macro cells, micro cells. So depending upon that, we are giving the name as urban macro, small urban, suburban, micro, etc. First, we will see the long-term evolution channel model for path loss. So, by coming to the name, we can guess that it is used for the outdoor macro and micro cell environment. Okay, and also this will be referred to as 3GPP channel model, that is third generation partnership project models. Here, before going to be used, we need to specify the environment, whether it is a suburban macro or it is a urban macro or it is a urban micro. First is the selection on specifying the environment scenario or nature. And also we should keep it in the mind, base station to base station distance is larger than 3 kilometer, that is for the macro cell. And if you go for the urban micro cell environment, it is less than the 1 kilometer. Now, if we consider the 3GPP macro cell environment, the path loss is given by the cost, that is COST, HATA model, that it is easy to compute the scenarios. That is nothing but PLC, where in terms of dB, some statistical values they have given, and HB, they have in the formula itself they have mentioned HB, that is nothing but base station antenna height, then F suffix E, carrier frequency, then D, distance between the base station and the mobile station in kilometer, and the A of HM, that already we know that the correction function for the mobile height, and A of HM we don't know, but it is also having a statistical value which is mentioned in the formula, and HM is nothing but mobile antenna height, and HB is base station antenna height. Now coming to this LTE channel model for multipath. So here we can say N type of delayed versions of the transmitted signal. Okay, here we can see this is the base station array and this is the mobile station array. So one end. So we are aware about that the signal is going to transmit from the transmitter to the receiver, that we will call it as base station and the mobile station. So there will be a cluster, subpath, and we have decided already 5 parameters, that is angle of arrival, angle of departure. So these all things are measured or represented in this diagram. So now the path, how the ranges will be happened for the number of path, that we will represented by capital N, and the ranges will be like 1 to 20. Okay, and all these ranges will be represented or dependent on the specific channel model. Example, we can consider n is equal to 6 multipath component and the power distribution normally follows the exponential profile. Okay, and if you go for the multipath component, in the diagram itself they shown that there is a cluster, so that is nothing but the cluster m subpath. Okay, and then we will go for the LTE semi empirical channel model. Here it will provide the accurate inclusion of the practical parameters, and it will maintain the simplicity of the statistical channel models. So now come, we are very clear and we are able to distinguish about the empirical channel model as well as the statistical channel model. In the empirical channel model, we are considering the environmental scenarios such as suburban, macro or micro. We know it is a macro, it is the cell size, or this will be more than the greater than the 3 kilometer and less than the 1 kilometer. By considering that mobile station transmitter as well as the receiver, we are going to analyze the angle of arrival, angle of departure, and the 5 parameters what we have discussed in the earlier. And here let us see the empirical status models, and here the one thing is the power distribution is in terms of exponential profile, so that we can clearly understand that the power is varying at what instant of time, in what scenario, and it is decreasing. So and also in the diagram it is very clearly they have given subpath m. Subpath m and cluster n are is the important parameter which is going to be give the result. And here we have base station array, broadside array. Already we know there are two types of arrays, end fire array as well as the broadside array. Here we are using the base station array in broadside array. We are following the concept of broadside array. And here when the dotted line is indicating the mobile station direction of travel, such a way we are going to track the received signal at the mobile receiver, which will consist of n time delayed versions of the transmitted signal, so that it will be very easy to clarify the power distribution, which is in terms of the exponential way. So followed by this, let us discuss about the semi-empirical channel model. That is only the thing, it will provide the accurate inclusion of the practical parameters in a real wireless system, and while the same time it will maintain the simplicity of the statistical channel models.